Welcome to my first presentation about structured error handling. The presentation that I gave a couple years ago for the first time, I've updated it. There's some new features, setting the focus at different parts, different topics. And experience from my activities as a consultant is still many developers are asking, well, how to use it and what to use it for and so on, and trying to give some answers to these questions. So, quick intro. Consultingwerk, we're supporting OpenEdge developers, typically at application partners, but also at end customers that do their own development. Main office is here in Cologne, we're still debating whether it's 2 or 3 or 4 minutes walking distance from here. We have other offices in the UK and in Romania, and we have colleagues working from home office in the Netherlands and supporting customers, almost around the world. One of the areas that we support our customers with is our developer framework, the Smart Component Library. It supports developers with, architecture best practices, so following the OpenEdge reference architecture, common component specification, various OO patterns like OpenEdge relational object relational mapping and domain-driven design. We provide user interface flexibility and various other features. I have a session on that topic tomorrow for those that are interested. And my role at Consultingwerk, besides being the director, is I support customers as an architect in modernization projects, and I'm the product manager, architect, and very often developer of our toolkits, the Smart Component Library and the WinKit. I like object-oriented design, software architecture, these kind of topics. I'm using Progress for over 30 years now. Started with version 5. This long-lasting experience helps me a lot with, understanding modernization challenges, I believe. So, structured error handling. I'm going to talk a little bit about traditional error handling, and then I dive into the structured error handling. Explain the new feature there available since OpenEdge 12.0 for handling stop conditions. And I have a sample built around the HTTP client from Progress software for error handling there. And I will probably not be able to talk about the best practices, but I'll leave them in the slides for those that want to read them later. So in the ABL, or the 4GL, whatever you prefer to call it, the documentation talks about runtime conditions. So something happens, something unexpected happens. So it can be a runtime error starting from you're trying to find a record which is not there, you're trying to open a query on a handle which has not been initialized, anything like that. Very often the fault of a programmer, because even if it's the fault of a user, the programmer should have avoided that. There may be application errors, so that are errors that you specifically raise from application code, like user trying to run a function that he's not authorized for. You could raise that as an error, and that would be an application error. Then there's these stop conditions, which used to be a problem when structured error handling was introduced in OpenEdge 10.1c, I believe. Stop conditions weren't part of it. And they're quit conditions, which is when you run the quit statement in your code, which I think is very rarely. So the classic error handling has always been a block-oriented error handling. So within a block, and that could be a for each block, a repeat block, or any form of for block, or a do block with transaction handling, has standard behavior for handling errors. Developers can influence that with the on error retry, on error next, on error leave directives. Most ABL developers use that intuitively, but if I would ask you what is the default error handling in a for each loop, you probably couldn't explain it, but you're intuitively doing it right. So probably a very nice design from Progress at that time. Some of the behavior, however, makes more sense in TTY style data entry, so in a classic update editing block. And this is if you run code, headless code on an app server. So things like you have the uninitialized query and you're trying to open that, that could lead to an infinitive loop on the app server. Whereas in a TTY repeat block, the user would get the chance to cancel that. So that's why the environment in which we run OpenEdge has changed, and that's why the requirements for error handling have changed. What always happens when one of these errors occurs, whether it's an application error or a runtime error, AVL stops the execution of that block. So the statements in that block after the statement that caused the error are no longer executed. I think that's expected. Then the default behavior is to display the error message. The transaction of that block is undone. And then happens the so-called branch action, so that's the retry, leave next, based on the block default or the directive. And based on the block type, there are different defaults. And unfortunately, it's also dependent on whether it's user input or whether it's an iterating block. So the do transaction, when there's user input, the user gets a chance to correct it. So you have an update statement, that's user interaction. Then a validation fails, well, then you undo retry, which makes a lot of sense. You show the user an error message and he can retry his entry. In an iterating next, there's no user that could fix something, so why try again? And if it's neither user input or iterating, then we are in this otherwise column. So, and I think none of us here in this room could write this table by heart. If one can do that, I have a lot of respect for you. Or maybe not, maybe you spend too much time reading the documentation. So problem is sometimes this doesn't work as expected. So I have a handle variable defined here, and I try to do a buffer copy of that handle within a for each loop. So that's one of these things where when you execute that, you first see this message, and then this message. These two messages, different text, mean there's one error with two messages. So now the behavior of this block is retry, or next, whatever. And we get these infinitive blocks of error messages. And I don't think they're helpful for anybody. So that is one of the issues with the classic error handling. Other issues is if you want to handle errors with classic error handling, really the only way you have is using the no error option on any statement that supports no error and checking if error status error. There's no way to reset error status error. So if you check here for an error and then later, you might be assuming, oh, I'm checking for the previous statement and the developer forgot the no error statement there, so you're actually showing the previous error message again, or you're dealing with it again. And that's quite annoying. And error handling should be something that isn't error prone. So that's where structured error handling or the various elements of structured error handling come in handy. So structured error handling is an alternative way of handling errors in the AVL. And it adds error handling constructs which are very well known from other OO languages. And I'm saying other OO languages now because the AVL has become a true OO language too. But developers coming from C# or Java know it from there as exception handling. In the beginning, Frogus did not want to use the exception handling because they said it is not complete as long as stop conditions are not part of it. So now we could actually call it exception handling. It uses some OOAVL elements, but it's very well usable with procedural code as well. And I truly recommend that, that you do that. And it has been started in 10.1c, and there were extensions in the language up to OpenEdge 12.0, which was, I think, released 3 years ago or so. So it has been an ongoing development since then. And one of the first elements that every developer should start using frequently is a finally block. Every block, so in a 40-year-old procedural for each or repeat or whatever update editing statement, you could and should add finally blocks, like you should do in modern OO code. The finally block is executed when the block succeeds, when it errors. If it's an iterating loop, like a for each, the finally block within the for each is executed for every iteration, so for every record. You have a dedicated cleanup block. You can nest finallys, but then it gets sometimes a bit funky, so a finally block could have errors too, and then you could have a nested finally in the finally block. Finally and catch blocks should be written in a way that they don't error, because it gets complicated when they do that. And you should make it your personal routine whenever you write the create object statement. It should hurt your brain cells if you're not immediately writing a finally block. And if there are exceptions, when you don't want to do that, you should be writing comments explaining why it is an exception here and you don't want to finally block off to delete that widget. And it should be also your habit that if you try to delete something, you test in the finally block if that object is valid. Because if something errors before the create query, the delete object statement would fail, and instead of the error that happened before, the user would only see the error raised from the finally block. So an error in your error handling or cleanup code would actually invalidate the actual error that was there. And nothing is more complicated than hunting a bug at the wrong place. So in the finally block, really be careful. Always check if things are valid before you delete them, for instance. And then there are now catch blocks. Catch blocks can also be used with procedural code. So for each block in a .p file can have a catch block. Catch blocks are the block to handle runtime errors in the surrounding block. That's something where Java and C# developers need to get used to. In Java and C#, the catch block is after the block, and in ABL it's within the block. That's because we don't have a dedicated try block. And when you use catch blocks, what happens? The block execution stops at the statement with the error. The transaction or subtransaction is undone too, and then the catch block is executed. Within the catch block, you can look at properties of the error object. So for a progress runtime error, you could, for instance, inspect the error number to see if it's a record not on file or something more critical, and decide how you act based on that. So in the simplest case, well, we have a block, a repeat block. We have an update statement. We have a find without a no error. It's very important now to not use no error, because no error suppresses the error. Then you wouldn't get into the catch block. But when you have the catch block, we're getting into the catch block when the statement errors. And well, in this case, I'm just displaying an error message like this. But you can do more with catch blocks. You can have multiple catch blocks in the same block. If we look at the catch block on the slide before, this here, the catch uses a parameter definition and a type there. So progress.lang.error, that's a type of errors that we want to handle there. If you want to specifically handle different types of errors, you could have multiple catch blocks in a single block. Those should be ordered from the very specific one in the top, two more generic types, because the ABL executes the first catch block that fits to the actual error. I'm going to show the hierarchy of errors on the next slide, or the one after the next slide. So it can look like this then. We have a block. Actually, I wouldn't need a block here. The procedure is a block too in the ABL. I run the internal procedure that returns an error. So that's the classic way of returning an application error, the return error statement. And then I have two catch blocks. One for the progress.lang app error, so an application-generated error, and one for runtime errors. So based on the type of error that occurs above the catch blocks, either of those is executed. One of them, not both. So the first one, that's matching. So, and Progress has, as part of the documentation, this little UML diagram of the error classes. There are 3 error classes provided, or well, there's the abstract pro error class, but the errors that we will be seeing at runtime are the sys error, the app error, and the SOAP fault error. If you're not using the SOAP client, then you can forget about that one. So we either have the runtime errors invalid handle and you're trying to execute open query on that, or record not on files, that are all progress length sys errors. And the app error is that we as a programmer can actively raise. They all implement the progress length error interface. That's this one. And if you're using GUI for .NET has been integrated into that too. So it's completely unknown to any .NET developer, but for us AVL programmers, the .NET exception also implements the progress length error interface. That's something that Progress hammered into it in the bridge. So, and in the Developer Studio, we can use the class browser to look at the class and its properties. So the sys error, the error class for Progress runtime errors, has properties which are similar to the error status widget. So we have the num messages property there. We have methods for reading out the error message string and the error message number. And there's a property for the call stack. And that's quite useful because that's the property that we can use to see which line has caused the actual error. So, and for us as programmers, we can create our own error classes that inherit from the progress.lang.app error. So if we programmatically raise an error, it could be the app error class, but once you start more like thinking about reusable functionality and more like this framework thinking or templates or whatever, then writing your own error classes is something that you will quickly add to that. And that's quite easy. You just write a class. So this is now the point where you need to start writing classes. Everything else now, catch blocks, finally blocks, is the same with procedural code. But your own error types need to be classes. So you write a class that inherits from the progress.lang.app error. You can have constructors, you don't have to have constructors, you can have your own properties on that. Errors are usually relatively passive classes. You don't write code that actually does something, they just carry information around. So more like a structure than a real class. And then when you have code, like here I'm running the test procedure and I'm going to the test procedure and I'm checking for the user ID. And if I'm not happy with the user ID, then I use the undo throw new and then the class name to create a new instance of the error. And with the undo throw, I'm erasing that error. So, and what that means now, the run statement will return with the error. And within the error, I can catch it. So we have now here this not authorized exception cat block. And I can use the properties of the error, like the function name, and use them in my error handling. So inform the user what he's not authorized to do. I don't think I mentioned that earlier. That's a little bit annoying. When you have multiple catch blocks, you cannot reuse the variable name that's referencing the error. So it looks like a parameter to a method, but it's actually scoped to the whole method or procedure that it's in. But the compiler will be nice and tell you about that. And so that would then be the error message that we would be seeing. So to raise these errors, we can use one of these syntaxes. So we define a variable of the error type, create a new instance with constructor parameters, assign property values, and then use undo throw error. Or in short form, we use the undo throw new error, so if we don't need additional properties to assign. Or, and that's more for the classic programmer, we use the return error, new error class name, and then in parentheses the constructor parameters. I don't think I ever use this one here. Because, well, it's easier to do it all consistently using the new syntax. When you throw errors using the new syntax, there's one thing you need to be very careful about. And I would really call that a design bug of the app error class. So the app error class is the class for errors, the base class for errors raised by the program, not the progress runtime. And it has three constructors. One without any arguments, one with a character, one with a character and an integer. And if I would look at this in any other class reference and I see, oh, there's the integer as an additional parameter, I would consider the integer being optional. But what happens here is the integer, whether you use it or not, changes the meaning of the character parameter. So this one here is creating an error without a message, but with the return value property. And the second one creates an error without a return value, but with an error message. And the difference is, if you do a new app error, any string, comma 0, that message will be shown by default by the ABL. Because the ABL detects that, and we're in the normal standard error handling of the ABL, and it will show the error message. But if we do a new app error with just the character, nothing will be shown, because the ABL says, hey, it's an error with a return value. There's no default behavior in the language to display return values. So it is dangerous. To a degree, it's consistent. So, but these two undo throw new app errors, they look so similar, but they behave so different. So be careful with that. So it actually doesn't make any difference which number you use there. Could be 0 or 42 or whatever. Could be a meaningful number. That's not shown, but it changes the behavior. So the next thing that has been introduced is the throw option on blocks. So on the for each customer, on error, undo, next, undo, leave, undo, retry has been there in the language since, I don't know, 30 whatever years. Now a new option was added, on error, undo, throw. And when an error is thrown, it is not handled within the current block. It is thrown to the next block. And that block could throw it further until somebody cares about it. It's like a hot stone, you touch it, onto the next one, and he catches it and may not like it and catch it on. So that means if you have an unfixable runtime error in a for each block, it will not execute any further. The for each block will be terminated and the error will be thrown to the outer block. So like this. So if we do it like this, first error, the second message is the second message of the first error. It's not a second error. And then this is gone. So the only difference here to the earlier case where the whole screen was full with the message was the on error, undo, throw. And that's actually what you definitely want to have in all modern code. The exception is pretty traditionally written ABL GUI and TTY code. There you might want to stay on the traditional error handling, but for all modern code, do that. Problem, a procedure, an internal procedure is a block too. But there's no syntax on error, blah, 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 for a procedure block. That was just not introduced. So what Progress introduced instead, so we do it like this, we still have all the messages. What Progress introduced instead is the routine level on error undo throw and later a block level on error undo throw statement. If you use that statement at the beginning of your procedure, like this, then the error from the procedure, which is considered a routine level block, will be thrown. So with this, we only get the messages once. And in 11.3, block level on error undo throw was added. So that's really for all modern code, I think, mandatory. The block level on error undo throw means the default for every kind of block becomes the throw. So not just the routine level blocks, the internal procedures, the triggers, the functions and methods and so on, with block level everything. So that should become your default whenever you're on any version. So that means I don't need any on error here, I don't need any on error there, because all blocks will inherit the block level on error undo throw. Also here we only get the message no once. One thing which I do not recommend, but I think it's not that relevant anymore, is because 11.3 is such an outdated version. I've seen people that were using a pro version preprocessor switch to switch between routine level and block level and compile it once on 11.3, 4 and older versions. I think a developer should understand how code behaves in case of errors, and this adds ambiguity, so that's not a real good idea for there. So, when we catch an error, we can inspect the error object. So in this case, I'm using the progress-lang error, so any error class there. And basically what I do is I ignore the sales rep record not on file error message. I have found out, and the only way to find that out is trying it out, that the sales rep record not on file is 138. That's the progress error message number. Word of warning, an invalid find on a temp table record is a different error message number. So really try that out. So then I say, well, if I get into this catch block, I can say every error which is not 138, I throw away. So invalid handle errors would be thrown away. So somebody else could be dealing with this. So that basically means I'm expecting a certain error and I do something with it here. It's just ignoring it here, but yeah. So, with this rethrowing, what we always do, or very often do, is when we expect certain errors, sometimes you can correct them, sometimes you know that a runtime error is actually something you would want to have a more user-friendly or more debugging-friendly error message, then we throw a different error. And all those errors that we don't expect from here, we just throw them away. Because if I don't have any meaningful to do with an error in a catch block, throw it away further. Maybe somebody else knows what to do with this error. And I'll have an example for that very soon when I talk about the HTTP client. Stop conditions. So stop conditions are a bit more nasty. Stop conditions are more critical system errors. So executing a non-existing .p file, the R-code CSC of a trigger does not match the schema, or the schema CSC in an R-code does not match the current schema anymore. You're trying to execute an R-code that requires a database, any of these things, which are more like setup related than real runtime errors. We have the stop after. Stop after is a feature in the language that allows us to say for any block the number of seconds that this block is allowed to execute. So if you have a slow query in a backend of a web application, I think something like a stop after 5 is always a good idea, because no user on a website would wait longer than 5 seconds for the result of a query. Unfortunately, stop after was causing a stop condition, and that made stop after handling quite nasty, because the only way you could handle it was like any stop with a do on stop. And then to figure out whether it was stop after, you could check the time. If the time was around 5 seconds, so it was somewhere between 4.9 and 5.2 seconds, then the chances were quite high that it was stop after and not running an R code which was miscompiled. And yeah, that's not really good. Trying to get a record lock, these things. So, and stop condition, the traditional handling was also kind of funky sometimes. It undoes all blocks until it reaches a block with an on-stop block. But the AVM could decide to skip that on-stop phrase and go further. And that was especially the case when the lost database connection was the cause. Because then an on-stop that was still in a procedure with that database connection required was also just missed. So eventually that always caused a client restart. And finally, blocks have not been executed. Ta-da, ta-da. So the AVM was restarted, and all the dynamic query handles was left in memory. And dynamic temp tables with lots of DBI blocks and all that stuff. So that was nasty. So in pack of 11.7, Progress has silently introduced a better handling for stop conditions. you had to enable it using the minus catch stop 1 startup parameter. In OpenEdge 12, the minus catch stop 1 is enabled by default. So this was kind of like a hidden public beta. Peter, can I call it that way? A hidden public beta? It wasn't documented either. So if for whatever reason you need to get back to the old error handling for stop conditions, and I really wouldn't know a reason, you could revert to that using the minus catch stop 0. And tell me why you do that, because I'm really interested. Progress has introduced a number of classes for stop conditions. And that's a little bit confusing. Progress has decided that there are stop conditions that are now more like errors. So running an R code which is not properly compiled is a stop condition which is considered being an error. But the stop after is now its own class. The log conflict is its own class. If the user presses control break, is its own class. And the other stop, which is like for really system errors, is also its own class. And if we now look at this as a UML diagram with the stop base class and the 3 classes deriving from that, and we have the stop error, which derives from the this error. This is weird on the UML diagram, but it makes a lot of sense when you're dealing with it, because that suddenly means that the running a .p, which is not there, which previously was a ugly stop condition, is now just a runtime error, because the progress length this error is implementing the progress length error interface, so that is the default catch block everywhere. So it makes a lot of sense. And these errors actually have messages attached to it. The log conflict stop after user, they don't have messages attached to that. The idea behind that is probably that if stop after is raised as a class, you can check for the error class, and then it's clear what type of issue it was. And then if you have kind of like a default error handler, could be an include file, for us it's an include file, then it would be having the progress length error, and then you could display the error message or display much more details. And for the stop, you have to distinguish by the class. And within the log conflict, for instance, you can see which is the user that's locking your record. You can see which table is locked. You do not see the rec ID of the record, which probably a lot of people will be asking for, but you can see customer record is locked by whoever, so those details are present in that error class, for instance, in that stop class. Is there a question?
Yeah, there were a few questions that came in that I missed. So just before we get on to that, the first one was from Ivan. How would you check if app error is thrown in a finally block?
How do I check?
If an app error, I'm not sure if it's an app error is thrown in a finally block or was thrown from a finally block, but in a finally block, can you check that an app error was thrown?
What sometimes is needed is that within the finally block you know whether any error was thrown, and you can only do that with a variable in the method, a logical variable, L-error, that in each catch block you set to true, and then you can check that in the finally block. To check for errors in the finally block, you could have a catch block in a finally block. So whichever way Ivan was asking for.
Okay. Second question, actually all 3 questions from Ivan here. Bad, good practices to deal with temp tables in a finally block. And I guess that came, I would guess that came from the catch you showed on the find error. Okay.
The question was best practices for dealing with temp tables in a finally block. That depends on many, many things. If it was a temp table that you populated to build a result, and the temp table itself is not the result, then it's probably a good idea to have an empty temp table statement for that temp table in the finally block to make sure that those records are removed. If, however, it's a temp table that you're getting as a by reference thing, temp table passing in this language is way too complicated. Then you probably don't want to delete the records in the finally block. So that really depends on what this code is doing. If it is the output table parameter, then you can have the empty temp table statement there, and it's going to be delayed until you're returning from that procedure.
Thank you. And final question for now. Have you managed to throw a custom app error to an old school GUI app builder window?
Can you, or how? Can you is easy, yes. So in the old style GUI app builder window, you should also just get into the habit of having something like this code block in an include file. So for us, and that's actually one of the best practices, which I will not get to. So if I create a new procedure, and since we're using Prox Developer Studio bit on steroids, we add always this Consultingwerk Windows UI catch.i include file. And if you look into that, it has 2 catch blocks. We have a little bit of more preprocessor code around it because we still may need to support the code on 11.6 or 7 before the stop after. And I use the same catch blocks in app builder code, in ABL GUI code. Also if I write it manually. And we use it in every UI event handler. So every on click of a button, on default action of a browser, on whatever in ABL GUI, I use my catch block.
That's an important thing to know, because in the .NET event handlers, the errors aren't thrown back. You have to catch them in the .NET event handler. They don't get thrown out to the wait for. Sorry, and then just one more question. Similarly, throwing and catching app errors to a Proxygen SOAP service. So I don't know if that would be on the client side or in the Proxygen P code.
Proxygen SOAP service. So those, I mean, that's like an app server call. I would expect that that's translated into a SOAP fault message. But actually, since PassOE and web handlers being the best thing since sliced bread, I don't think I ever used the web service adapter anymore. My expectation is that they are being thrown as a SOAP fault to the SOAP client.
Thank you.
And Peter agrees with my assumption. Good. That was actually for the code before. So let's talk about the HTTP client. So Progress has an HTTP client in the language since, I don't know, 11 something, 11.5 or so. Peter Judge was one of the original authors of that, so he knows a lot more about it than I do. And I think a lot of developers are using that already to interact with third-party applications. We use it for querying Jira tickets, for instance, or creating release notes on Confluence. It's really nice. The only thing which is a bit too difficult is dealing with SSL certificates, but that's a different topic. The other thing which I would hope for a different solution is when the HTTP call fails, so I try to access a resource which is not there, like a Jira ticket number which is not there, it does not throw an error. It just returns an error status 404. The HTTP clients in other languages throw errors in those cases, and I find that more intuitive. So I'm going through with you now through how to change that behavior. So here's like the basic code to do a request to Jira for fetching an issue. So I'm parsing the URL and using substitute to build the correct URL. I'm making the request to Jira, and after the execute, I'm just assuming that in the response I have a JSON object with the details of that ticket. So, however, if the ticket number is invalid here, this silently returns me a text response and an HTTP 404 code. And the text response, if I try to cast that to a JSON object, I will get an invalid cast error. Yes, I should always test, blah, 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 blah. But I think the API should throw an error at me when something unforeseen happens. And this is the problem here. The actual error happens during the request. The website, the web address I'm trying to reach to is not valid. And I never see that error, because what I see is the error on this return cast. There I see the cannot cast the OpenEdge core string to a JSON object error message. So I'm not seeing the actual source of the error. So I want to change that behavior. And Progress allows that. And now it becomes quite OO heavy. I don't want to change the code of the HTTP client, and I'm talking about that in my afternoon talk today. But Progress allows the use of the decorator pattern with the HTTP client. So I can put something on top of that without you ever noticing it. And then the consuming code, when it calls the execute on the HTTP client, actually calls into a decorators, and that's the class that I can write and enhance. And the decorator then calls into the OpenEdge HTTP client. And the consuming code does not need any change. It's something that I register up front. And the decorator, what it does, here it's passing on the execute request to the decorated HTTP client. I'm not using inheritance here. We're actually having an instance of the original HTTP client and another object that extends it through the decorator pattern. And within there, I have a method, and that's the real method that we're using, that handles an HTTP error. And I'm expecting a couple of error types that we know about. And we have written actual Progress classes for each error. So I can have a catch block for an HTTP 404. And I'm using dynamic new. I could also have a big case block there and throw this error from there. And now I can have code when doing the HTTP call to catch the HTTP 404 exception. And that's quite convenient. And then I can create a more high-level exception, inbuilt Jira key exception. So somebody that wants to interact with Jira might want to know that it was actually a request and it is the inbuilt Jira key issue. And the other thing that we have implemented is we have implemented errors that have the original error as an inner error. So when we catch the HTTP 404 and throw the inbuilt Jira issue exception for that, we leave the original error as a property in that error, so that when you're inspecting it, you see this, okay, Jira issue key SCL 4334 is not valid. You click more, and then you see the, okay, that was actually in 404 HTTP error. And we also have within the error, so that's now using reflection to inspect the error classes. You actually see the web address and the credentials and whatever that was used to try to make the request. So we have a lot of context in here. And I'm going to run through that code quickly live. I need my glasses for that. So, so I'm getting access, that's also something I talk about in the afternoon, to a service that knows how to interact with Jira, and I'm just requesting an issue with a certain type, and then I have my standard catch block there, which does not just use a message statement, it uses GUI for .NET dialogues to show the error on the screen. Within the Jira client, we have the code that does the request, and like I had on the slides earlier, we're catching the not found here and throwing then the invalid Jira exception class there. And I pass the original error as an argument into the constructor so that we can keep it within the object. And within our extension to the HTTP client, we're having this code that translates then the HTTP errors into its own class. So that's basically where we're putting all the various features of the error handling together. So we have catch blocks, we rethrow errors, we inspect properties of errors, we create our own error classes and so on. And when I run this code, this here, so I'm getting the error class that was expected. I'm getting all the stack trace information because that's important. So I know where the error came from, where it was raised, and I can see the other error, the inner error, can see where it was raised. I can look into the properties of the errors because they're preserved as properties in the class and with some reflection. Peter will be talking about reflection today in the afternoon or tomorrow morning. And that's a nice way to do this. And we do similar things for logging errors to files and so on. Good. So I'm 5 minutes past my time. That's exactly the 5 minutes for the record that I started later. And I leave the best practices for you when you get the slides. Good. Thanks for your time.